Hello class, I'm here to talk about chapter 4. Chapter 4 is introducing us to linear programming in different business areas, right here, marketing, finance, operation management. So please go ahead and take a look at the chapter. Chapter 2, if you remember, introduced us to LP, to linear programming, where we learn how to graphically solve a problem. We learn how to read the constraints, get the optimal solutions, and all the basics of the linear programming. On chapter 3, on the other hand, we have been provided the output of a sensitivity analysis report based on the LP, where we could determine dual values, allowance decrease, allowance increase, um, slacks, or which constraints are binding or not binding based on a computer solution. On chapter 4 now, you're gonna have to learn how to put all the constraints together. What is the objective function? What is your optimal solution? But you also now gonna be developing the report, the sensitivity analysis report, and being able to answer the questions. Okay, so I have posted a video for problem 3. The video was a pilot for the videos that I recorded for you today. So please go ahead and read the problem, and you're gonna notice that on the template, I made a template available as usual, and you're gonna notice that I put all this information and to show you where I'm getting all those numbers, where, for example, right here it says that the risk free securities may not exceed 30%. Therefore, I did put a note that $2 million times the 30%, you're gonna see a value of $600,000. Right here on the second one, it says the signature loans may not exceed 10% of the all funds investing all loans. Therefore, they have invested 10% on the automobile, furniture, other security, and signature loans. However, on the signature loans may not exceed the 10%. So you're going to do the 100% minus the 10%. So you're going to have 90% for signature loans minus everything else, 10% for the others. And then that's how the numbers are showing on your template. You just have to go ahead and put everything in solver. Um, and now I'm going to go over problem 5, and we're gonna be putting on the template, which I have it right here. I have put the problem over here, so I'm gonna be closing the book, and I made the template. One thing that I want to mention is, I believe I mentioned that every term, and I'm sorry, I have some allergies, so I'm struggling a little bit here. Um, you don't have to follow exactly what I follow. This is the way I like to develop these problems. So this is the format that I prefer, that makes it simpler for me. You may find a better way, and that's fine with me. As long as we get to the same results and the same conclusions, um, really doesn't matter which format you have used. And as long as also I can see how you got to that solution, that means your calculations, which on your final exam, if you have a question that I noticed many of you last week, if you have a question that asks you to give the values, but also you got to give an interpretation, if you only provide the values, you're only getting half points. Okay, the point here is to tell me what you have learned, what you understand for from those numbers. Just giving me the numbers, yes, it's I'm glad to see you can get to the results, but really, in the end, we're talking about managerial decisions. So just giving the numbers to your boss is not gonna matter as much as you giving your own analysis of the numbers. The same thing you're doing for your final paper for the other cases that you have developed. Okay, so let's go ahead and start with chapter 5 or problem 5. Kilgore's Deli is a small deli located near a major university. Kilgore's does a large walk-in carry-out lunch business. The deli offers two lunch on chili specials. Okay, so one is the Wimpy and Dial and the other one is the Dio 911. Well, what I understand that since these are chili specials, I believe the Wimpy is those are for the people who don't care for hot sauce, and the Dio 911 are for those who really like hot sauce, like myself. At the beginning of the day, Kilgore needs to decide how much of each special to make. He always says out of whatever he makes. The profit on one serving of Wimpy is 45 cents. Profit in one serving, which you could go ahead and even change here if you want to profit per one serving, um, is 45 cents. On one serving of Dio 911 is 58 cents. So the way that I found better to identify all this is to call WinPW and to call Dio 911D, and I have put the values over here. Notice that right here we are going to be determining the decision variables. This does not mean dual value. This means decision variables. If you don't want to put like this, just put variables so it doesn't confuse you. I just didn't want it to be too big, the column. I don't want you to get confused, okay? So let's continue with the problem. Now it tells you, you're gonna notice how we're getting to the constraints, because right here is going to tell you how much of each and it's going to tell how much they have. Those therefore are your constraints. Another thing that we have to determine here, they're talking about profits, therefore they're talking about maximizing, so it's a maximization problem. Okay, so this is going to be important when you use solver. You're going to have to determine whether you're maximizing or whether you're minimizing the values, and right here we're talking profit, therefore I can't think of anyone that would like to minimize their profits. And if you do, please go ahead and mention on your discussion thread, which I have pretty much this is what we're covering this week. So let's go ahead. The profit on one serving of Wimpy. Okay, then each serving of Wimpy requires 0.25 pound of beef. Okay, so the best way I put it here, the constraints, and I'm gonna do that. We have 0.25 Wimpy for beef. Then we have 0.25 cup of onions for Wimpy. We have, I'm reading right here, each serving of Wimpy requires 0.25 pound of beef, 0.25 cup of onions, and 5 ounces of Kilgore special sauce. So, in 5 ounces of Kilgore special sauce. Be very careful. One thing I noticed when you're dealing with 0.25 and 5, these are two different values, okay? It's a quarter and this is a whole number. So it will change definitely everything if you put a 0.5 here by accident. Okay, we don't have anything for the hot sauce for Wimpy. And as far as no negative, you're just gonna have to put that Wimpy and Dio 911, they're gonna be higher or equals than 0. Okay, a non-negative number. So let's go now to the Dio 911. Each serving of Dio 911 requires 20.25 pound of beef. So here it requires 0.25 of Wimpy and 0.25 of Dio 911. Now it requires zero point 0.4 cup of onions, so 0.25 of Wimpy plus zero point 0.4 of Dio 911, 2 ounces of Kilgore's special sauce, so 5 ounces of Wimpy and 2 ounces of Dio 911, and right here, and 5 ounces of hot sauce. So right here we only have Dio 911 for hot sauce, since that's the one that they added more to make it spicier. And now it tells us today Kilgore has 20 pounds of beef. Therefore, this combined with is no more than 20 pounds 15 cups of onions, so no more. We cannot use no more than 15 cups of onions. Special sauce, 88 ounces of special sauce, so we no more than 88 ounces for special sauce, and 60 ounces of hot sauce on hand. So 5D of 5 ounces of Dio 911 cannot be any more than 60 ounces. Okay. So now we can go ahead and put down here. The questions are going to be, first we're going to develop the LP model that will tell us how many servings of Wimpy and Dio 911 to make in order to maximize his profit today. The second question is going to be to find an optimal solution. Well, we can tell servings, but we also want to know in dollar amount. So find an optimal solution, which is what I'm going to be working here. And then when we have completed that, we're going to talk about the dual value for the special sauce, constraint 3, and we're going to give an interpretation. And then on D, we're going to increase the amount of special sauce by 1, is at 88 right now. We're going to increase that to 89. We're going to resolve and see if it confirms part C, because if you do remember, the dual value tells us that for every unit you increase on the right hand side, then you're going to increase that amount on the optimal value or decrease. Therefore, we're going to do that, increase one, solve again, and see if it's going to give us exactly the difference that it told us on the dual value. Let's go ahead and solve it so it makes more sense. Well, right here, for the decision variables, that's the result that it's going to give us, correct? But we also want to know in dollars how much is going to be. So let's start by doing, it's 45 cents per serving, so times whatever we find in how many servings. And then right here, we have a 0.58 cents per serving in times whatever they define is the optimal value decision variable for servings. So right now, actually it's telling me I did something wrong because B2 times C2 and then, oh, not plus. See, I made a mistake. It's good this things happen so I can double check. So times, oh, Excel understands by this, sorry. So right now I don't have anything because if I put that, I determined that my optimal value for my decision variable is 3, or let's say it's 1, it's going to multiply 1 times my dollar amount. So it should say right here 45 cents. Here you go. And I say that for this, the dial 911 is 2, so you would do 2 times the cents right here. Okay. So once that is determined, I want to know the total for the total that we're going to make. So let's go ahead and sum this too. So once this solves, which I'm going to make it bigger for you, when solver gets us the optimal value for the decision variables, multiply by its dollar amount, and it's going to give individual values, but then I want to know the total amount, how much is going to be. So first, we have defined the formula for our solver for optimal value. Now we're going to go to the constraints. We have the left-hand side, which is before the sign, and then we have the right hand side. The right hand side does not modify. This is the maximum you can do. So right here we have 20, correct? No more than 20, no more than 15, no more than 88, and no more than 60, correct? 15, 20, 15, 88, 60. So I repeat it over here. You don't have to put anything on the no negativity one. We can do that in solver. So let's go ahead now and work with this left hand side. So what are you doing? What are you gonna do? You have 0.25 of W. So really it's a formula. So equals 0.25 times my Wimpy variable plus 0.25 times my dial 911 variable. So now you're just referring for whatever solver finds over here, they're going to multiply by these values. So now for the second one, we have 0.25 times my wimpy value plus point, I'm following this over here, zero point 0.4 times my di911 value. And now we have 5, not zero point 0.5, be very careful, times my wimpy value plus 2, not zero point 0.2, times my Dial 911 value. Over here, we're only working with the Dial 911 because that's the hot sauce they added to make it Dial 911. So we're going to do equals to 5 times my D, which is Dial 911. Okay, we have defined our constraints, and this is just to make easier on solver when you, or on you, when you go to solver now, everything, oh good. Okay, so now what is our objective? So our objective is to learn this value right here, the maximum dollar amount we can make by combining the servings of Wimpy and Dial 911. So my objective functions is on this cell right here, which has a formula in it. If it does not have a formula, solver will not be able to solve it for you. What do we want to do? This is very important. We want to maximize it, right? So correct, we're maximizing. Now, what are my changing variables? Well, my decision variables are right here. So these two are going to be the variables that I have to work to define all this. Now for my constraints, I could just go ahead and add one by one. But since I have the same sign and I have showed you this shortcut before, all you can do is to add all the left hand side, and then they are all smaller or equals to all the right hand side. You could go ahead and do one by one. That's fine with me too. It's just easier since it has the same sign. If you had a different sign, then definitely you're gonna have to do it separately. Make unconstrained variables non-negative, so all your variables are non-negative. Equals W plus D equals, it's higher or equals than 0. You don't need to, let's just leave it and make unconstrained variables non-negative. And right here, you leave it as simplex LP, which I told you that's the one we're using for this class. And then we're gonna hit solve and hope that it gives us a solution. So hit solve, and it gave us a solution. Okay, and then you're gonna be getting this little window here with these messages that he found a solution, that all constraints and optimality conditions are satisfied. Well, what do we want now? We definitely wanted the sensitivity report. You can go ahead and add the limit. You can go ahead and add all three if you want, but really we just need the sensitivity report. So let's do okay, and you're gonna notice it's gonna add right here some more worksheets. So this is your sensitivity report, and then these are your limit reports. So let's look at the results first. It told that we need 12.8 servings of Wimpy and 12 servings of Dial 911 to get our optimal value of $12.72. By look at this information right here, I'm going to make it bigger. If you notice, this value had to be less or equals to 20. It was only 6.2. Less or equals than 15 on the second one was only 8. But see how we use up everything for special sauce and for hot sauce. So just by looking here, if I would ask you which ones are binding, you could say constraint 3 and 4 because we have used up all the amounts, the ounces or whatever they're using at the problem right here. Okay, so again, 12.8, 12, and then the value 12.72. So let's go ahead to your limits report, and it confirms 12.72. It's your value, your optimal value. That would be your answer for B. Uh, the 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 variables, the amount of the variables that you need would be 12.8 servings for Wimpy and 12 for Dio 911. So that would be for problem A. Okay. Then let's go right here to this table, the sensitivity report. One thing very important that you can do on your final exam is right here. Now that we are a little further down, I can tell you shadow price is the same as dual value. So you can go ahead and change this dual value. in our values. And I'm sure now you remember the dual value tells you for each unity we increase on the right hand side, that's the value it's going to modify our optimal solution or also decrease. However, I also told you that right here is on this range of feasibilities, which this is what it calls, you have limits. You cannot go as much as you want because the moment you're out of the range of feasibility or the optimality, then you have to develop a new linear programming. So right here, when you see this scientific value, it's really an infinite amount because it goes forever. So what you can do, when you're calculating, if you want to go ahead and calculate all the ranges, so if I ask you, you already have all the values, how would you do that? Well, right here you can do that. Your final value, we're talking about your decision variables right here. So the allowable decrease, it's 0.45, and the allowable increase, I'm heading, is 13.8. Right here, this is an infinite. So really all we can do is to go ahead and insert a symbol and insert the infinite symbol and close over here. Okay, so let me put this in the middle and let me make it a little bigger. There we go. So now actually I just did it wrong. I wish this was the other way around. This is for my increase. Okay, for my decrease equals 12 minus 0.4. So my range of optimality for my variables is between 12.35 and 13.8 for Wimpy and 11.6 and infinite as increase for the Dio 911. What does that mean? As long as you stay within this range, then you're not going to need to develop a new linear programming. Okay, so let's go over here and do the same thing. For constraint number one, actually, one, two, three, four. Okay, yes, correct. Constraint number one, do you see how he put the cells, but I could have named them. You have a decrease, so 6.2 minus, actually, if we go all the way from minus 7.6 to, this is infinite, right? So you don't need to really make a calculation. Just go ahead and put it here. Same thing is going to be for the one down here. Do you see how it's infinite? So my increase is infinite. My decrease allowable is my final value minus my allowable decrease. And then you can do that for the rest. So equals my final value minus my decrease, and then equals my final value plus my decrease, increase, and then here is equals 60 minus my decrease. So you really don't have much, you cannot change anything. And right here to increase, you can increase up to 176.67. You could just go ahead and round it over here too if you want to go ahead and round it so you don't show all of them, but sometimes it's good to leave it like that because maybe your question could contain some digits. Okay, so now let's go back to the problem. So right here it told you that the how many servings of Wimpy and Dio 911 to make in order to maximize his profit today. Well, today would be 12.8 servings or about 13 for Wimpy and 12 for Dio 911. B, what is the optimal solution, which is a combination of everything. So my dollar value is $12.72. What is the dual value for special sauce? Give an interpretation for the dual value. So let's go ahead back. So the dual value for special sauce. First of all, let's go back here. Which one is my special sauce? Right here. So my constraint number 3 is my dual value, which you could go ahead and rename this to, okay, if you want it. Special sauce, so you remember. So my dual value, which is called also shadow price for special sauce is it can go from 24 minimum to maximum 228, and for every unit I increase or decrease there is going to be a change of 9 cents. So this is my allowable decrease, this is my allowable increase with the range of feasibility. For every unit that I increase on the right hand side of the constraint, my dual value is going to tell me by how much my optimal solution is going to either increase or decrease. Therefore, what is the dual value? The dual value is what I just said. For every unity of this special sauce, the dual value will either increase or decrease in 9 cents. Or you could say the dual value is 9 cents. So now that we know it's 9 cents, at 12.72, I'm saying that if I change one here, if I increase one here, this should goes up in 9 cents, correct? Plus 9 cents. So my next value should be 12.81. So question D tells you increase the amount of the special sauce available by 1 ounce and resolve. Does it confirm the answer to part C? So let's go ahead now and increase this to an 89. It should give us right here a 12.81. If it doesn't, then it's incorrect. So let's go ahead and resolve it. Well, since right here we refer to the formulas, you really don't have to change anything. You just need to change on the right hand side values. So let's go ahead and solve again and see what happens over here. Keep an eye over here. Solve. Here we go. And do you see how he automatically, because I refer to the cell, he automatically gave me a new value since I increased by 1. If I increase by 1, the next one is going to be 12.90 because I put 9 cents. But really, I should have typed here 12.81 because it's going to confirm what I just told you. So the 12.72 plus my 9 cents is 12.81. So it does confirm. So you can say, does the solution confirm? Yes, it does confirm, and then you give the new value, which is 12.81. And you would be done with problem 5. Again, I have posted a video for problem 3. I understand there is no volume, but please go ahead and look. I went very slow on the process so you could see each number, and there are several notes on the template as well, so you can see which value comes from where. And we will be done for the problems for this week. Please be aware that your final exam is going to be available this Friday. Classes finish next Friday, August the 17th. And your final exam, I want to give you a week to complete it. So it's going to become available this Friday. And we also going to be covering some more subjects on last week, week 8, which I'm going to be putting as extra credit on your final exam. Okay. And as usual, please do not hesitate to contact me if there are any questions.